Hello everyone, welcome back to the solutions for the ACET 2024 December paper. We are solving the maths portion. So question 15 from binomial theorem and question 16 is a general question from sequences and series. We would have to look into it. Question 16 is a bit more trickier. Question 15 is straightforward. So the coefficient of x to the power 20, right? X to the power 20. Before we get the coefficient of x to the power 20, let us write down the general term instead. So what will be the general term for this? The general term for this will be written as you have learned in your binomial theorem. So this will be 24 CN, right, because there are 24 terms. X square will be of 24 minus n, and minus 1 by x square will be n times. Okay, so what do we want here? We want to gather the powers of x together, right? So this will be 24 CN minus 1 to the power n. I can separate out, and I have x square, okay, x to the power 48 minus 2n, right, because I can multiply the powers, and then I have to subtract something. What will I subtract? I'll subtract minus 2n, right, because this is x to the power minus 2 to the power n, so x to the power minus 2n, product minus 2n. So this will turn out to be 24 CN minus 1 to the power n x to the power 48 minus 4n. Now to get the coefficient of x to the power 20, this has to be equal, right? This has to be equal to 20. So in that case 48 minus 4n should be equal to 20, which means 4n would be equal to 28 and n would be 7. So the seventh term would have the coefficient that we require. Okay, so now rest is easy. Calculate T7, the seventh term will be 24. Okay, clearly that is negative, right? So option A and C are options that are not to be considered. Okay, it is either B or D. So T7 would be 24 C7 minus 1 to the power 7, right? So this means minus of 24. Okay, we can write it like this. Now we know this property that, sorry, NCR is equal to NCN minus R, right? Using that, this is the same as 2417 negative, isn't it? 7 plus 17 is 24, so that makes these two equal. Now why was 24/7 not given as the answer? Because some of you would have made this mistake of not utilizing this property and marked option D. That is what the examiners want. They want to give you easy questions, but then they want you to go wrong in the answers. Okay, so this was a very common trap. Do not fall into this. Make sure that you remember this property, and that will make it option B. Okay, easy question. Now question 16. 16 is a bit weird because you would have to make some assumptions. I'll show you what kind of assumptions we should be making. See, we have sigma n equal to 1 to infinity 240 by n square plus 4n. Now 240 I can break it as 60 outside, and I have n equal to 1 to infinity 4 here. Okay, n into n plus 4. You will understand why I brought the 4 here looking at the denominator. So now this denominator becomes 60 into n equal to 1 to infinity n plus 4 minus n by n into n plus 4. So breaking down into partial fractions, we have 60 n equals to 1 to infinity 1 by n minus 1 by n plus 4. This is the sequence that we have. Now what does this look like? So enumerate the first few terms. So this will look like, of course 60 will be multiplied outside, so 60 times we would have, at n equal to 1 we would have 1 minus 1 by 5. At n equal to 2 we would have half minus 1/6. At n equal to 3 we will have 1/3 minus 1/7. At n equal to 4 we are going to have 1/4 minus 1/8. At n equal to 5 we are going to have 1/5 minus 1/9, and so on. This goes on till infinity, right? So what happens here? You can see that from n equal to 5, the terms start cancelling. If you put n equal to 6, the next term will be 1/6 minus 1/10. So this 1/6 will get cancelled. So ultimately, if you are going till infinity, apart from the first 4 terms, everything will get cancelled, right? So what are you left with? You are left with 60 into 1 plus half plus 1/3 plus 1/4, right? So you can take the LCM now. Take the LCM as 12. So 60 into the LCM will be 12, and you will be having here 12 plus 6 plus 4 plus 3, which turns out to be 25. So this is 5 into 25, which is 125. Now 125 is a perfect cube, right? Option D. Alright. So again, this was not so easy, but this question was a 1 mark question. So maybe for you this will be quite easy. When I was thinking about it, I tried to evaluate the terms up till a bit longer, which made the pattern clearer to me, that every pair after the 5th term will cancel out. And since you are going till infinity, you will not have a certain end point, right? Because let's say we went up to the 5th term itself, then you see only 1 term cancelled and 4 other terms remained, right? So if you keep going on towards the end, towards infinity, then what will happen? You will not have some point to end at and get 4 negative terms. Even if you take a very large number, say 1 million or 1 billion, you take a large number, the 4 terms that are on negative 2, 1 half, 1/3 and 1/4 will be very, very small. Those will be completely negligible. And since we are not calculating the computerized value, computerized value means we're not calculating it via computer, because if you take infinite in computer, you would have to actually put a very large value and get an approximation. So since we're calculating the theoretical value, we would assume that those values are 0, and you would just end up at 1 plus half plus 1/3 and 1/4. Okay, a weird question, but doable for sure. If you seem to get stuck in these type of questions in the exam, do not hesitate to leave this and move on. Okay, there is no compulsion for you to solve every question in the examination hall. You just have to score more than your competitor. Alright, so please make sure that if you are taking a long time in these type of questions, you do not stay here and keep working on it. Instead, move on to other questions where you might have a better scope of solving this. If you have solved all of these questions and you still have some time remaining after checking all the answers, then you can come back to this and try various methods. Alright, so with that being said, if you have any difficulty in revising all of these chapters, the binomial theorem chapter, sequences and series, if you need any help with these for revision classes, crash courses, mock tests, doubt solving, anything of that sort, do not hesitate to contact the numbers given on the banner. The mobile number you see has WhatsApp enabled, so you can drop a message there, and you could also send an email to the email ID that is mentioned. Our team monitors both of these contact points, so you can expect a swift response to your query. If you have any comment, suggestion or feedback for this video, do not hesitate to mention it on the YouTube comment section. The description of this video on YouTube will also contain important links to our institute, as well as details about the examination itself. So you can also collect the contact numbers from there and get in touch with us. Do not hesitate to contact us for any academic help that you might need. We will try our best to provide you with the help. With that being said, I'll end this video here. Thank you all for joining, and I see you all in the next one. Bye. Take care.